Welcome back, learners. So now moving on to our next set of questions, which are the application questions. We can begin, and our first question is asking us to look at this diagram and answer the following questions, or the questions that are following here. So let's just quickly study the diagram. We're seeing that we have 3 light bulbs, 2 switches, and 3 cells, or a battery consisting of 3 cells. So now, we need to now answer these questions. It says, what do you then notice in the following circuit diagram? On this diagram given to us here, what do we notice? Does it represent a closed circuit or does it represent an open circuit? We need to know what is meant by a closed or an open. Remember, if it's open, the switch needs to be open to show the disconnection between the 2 wires. So because here, there is no disconnection on our 2 switches here, this is going to show a closed circuit. Yes, it shows a closed circuit. Now, why are we saying that it shows a closed circuit? We are saying this because the ends of the wires are connected to each other. As we can see, the ends of all of these wires are connected to each other, and this allows for the current to flow from one terminal to the next. So the current will then be able to flow through these wires from one terminal to the next. Why? Because the switch is open and the switch is closed. If the switch was open, let's now say, assume that our switch here was open. If the switch was open, or let's just open it the other way. If our switch was open, when the current flowing through here, when it gets to this point, if it was flowing from the negative terminal to the positive terminal, through the wire, through the switch, and then through this wire, through that wire again, when it gets there, it wasn't going to be able to go to the other side or to travel through the wire because there is a disconnection. So in this case, the circuit will be an open circuit, or it will be an incomplete circuit. For us to complete the circuit, we close the switch. And closing the switch allows for these electrons, or for this electrical charge, to pass through the bulb, being our resistor, and then through the wires, and then back to the other terminal. So that is why we are saying that our circuit is a closed circuit. So now, moving on to the next one. Same diagram. We need to ask. We are asked, why do we think it's useful to have a switch in a circuit? So looking at that diagram that we had, or we can just draw another one here, whereby let's just draw it down here, or on the side. We can have any diagram with a light bulb. Another one maybe here with a closed switch. Now the question is asking, why do you think it's useful to have a switch in a circuit? Why do we need to have this, either it being closed or open? What is the importance of this switch in this particular diagram, or in any circuit diagram that we can have? Reason is, we need to be able to open and close the circuit. Why do we do that? So that we can control the current flowing in the circuit. So basically the switch is now allowing us to open it and to close it in order to control the current flowing through that particular circuit. So it's very important for us to have a switch. And as you know, it's very important for you at home to have that light switch when you're going inside a room that is dark, to switch on the light, and also to switch off the light when you go to sleep. That's the important thing, or that's the importance of that particular switch there, for us to be able to open and to close the circuit. For a closed circuit, that's us switching on the light. For an open circuit, that's us switching off the light, because we are disconnecting the wires when we are switching it off. So now, next question is asking, why are conducting wires made out of metal? The conducting wires, why can't you make these conducting wires out of a plastic or out of wood? Remember, first of all, metals, they are conductors of electricity. So why are we then making, why are they conductors of electricity, and why are these wires made up of metal? Reason is, these electrons that are inside the metal, remember that every metal is made up of atoms. And the atoms are made up of electrons, protons, and neutrons rather. And the electrons are always moving within that particular matter. In this case, the electrons they can be able to move freely within the metal. And remember, within the metal, when the electrons are moving from one conductor to the next conductor, that's now the flow of charge. We are basically transferring the electrons, and by transferring the electrons, we are allowing two different materials to have a charge, either a positive charge or a negative charge, depending on what happened to the particular electron. If an electron was transferred, then the metal or the material that transferred an electron will have more positive protons within itself, so therefore will have a positive charge. The one that gained that electron that was transferred will have more electrons and therefore be more negatively charged, and that's why now the electrons are able to move freely within a metal, because within a metal we have the delocalized electrons that are able to move freely within that particular metal. So now our next question wants us to complete a table, and in this table we're going to complete it by drawing the symbols of each of the components that are listed and then also give their functions. So we have the components, the symbol, and the functions, and the components are as follows. We have a resistor, a variable resistor, and then lastly a battery. We need to draw the symbols of a resistor, a variable resistor, and a battery, and then after that give their functions. So we know that a resistor can be drawn in one of two ways. The first one being the zigzag. We have this, and then the other one can be drawn like this, where we have a rectangle with the wires connecting this side. So therefore, when you're asked to draw a resistor, you can draw one of these two symbols to show that this particular substance is a resistor. Now, when you're talking about a variable resistor now, the symbol for a variable resistor is as follows. It's the same with the resistor, the first one, the second one, same symbol. The difference is that there is going to be a line or an arrow going across that resistor. So it's going to be that with an arrow going across the resistor. So when asked to draw a symbol for a variable resistor, you draw this particular symbol. We also need to give the function of the resistor and the variable resistor, and then lastly the symbol of a battery and the function of the battery. So remember, if it's one, we have a cell. If it's more than one, two, or more, we have a battery. So I'm just going to draw two. So this is going to be our symbol for a battery. If it's just one, then we have a cell. If it's more than one, it is a battery. Remember that this is one cell that consists of a negative terminal and a positive terminal. So if you have more than one of those particular substances, of those particular things, we now have a battery. If it's 2, 3, 4, or 5, now we're going to have a battery. Now, what are then the functions of each of these components that are given here and their symbols? So, a resistor, it limits or regulates the flow of electrical current within a electric circuit. So the resistor will do that. So that's the function of a resistor in an electric circuit. Whereas now, the variable resistor, its function is to adjust the value of the current or the voltage. Why do we do that? Because the variable resistor allows you to change the value of the resistance, because you're going to be able to manipulate the value of the resistance by you yourself changing the resistance of that particular resistor, hence variable resistor. And by so doing, it is going to now be able to adjust the value of the current or the voltage. Remember that if the resistance is high in an electric circuit, if the resistance is high, then the current is going to be low. So by us setting up a value for this, we are basically manipulating the current that you're going to be having within that particular electric circuit. If we adjust it to a very high value, then the current in that circuit is going to be low. But if you adjust this resistor into a very low value, then the current in that circuit is going to be extremely high, because now those two things, they have that relationship that when one increases, the other one must go down or the other one must decrease. So the function of the battery, it is written there now, it is to supply energy into the circuit. Remember, battery supplies energy in a form of potential energy to the electrons. Now, once those electrons receive or get that energy from the battery, they will start moving in one direction. Now, because the electrons are going to be moving from one terminal to the next, they will now have both the potential energy and the kinetic energy as they are moving through the circuit. So I've said a mouthful. Let's just go quickly for a short break, and I will see you just after this.